for my entire career, pretty much has gone in lockstep with the James Webb Space Telescope. And so for 20 years, we were reporting on the development of it, the ideas for it. And it is like the perfect example of the kind of story that I'm absolutely fascinated about. How do we see back to the beginning of the universe? How do we peer through the gas and dust that obscures newly forming planetary systems? Can we detect the trace gases of an advanced civilization that's polluting their atmosphere? James Webb is the machine to do all this.
Hello and welcome to the Wiser Tomorrow podcast. If you're enjoying these conversations, please consider liking the video and subscribing to the channel if you're watching on YouTube, or following and leaving a review if you're just listening on one of your favorite podcatchers. I hope you'll enjoy today's conversation, and please welcome Fraser Cain. So hello and welcome to the Wiser Tomorrow podcast. Today I'm here with Fraser Cain of the Fraser Cain YouTube channel, Universe Today, and Astronomy Cast. Across his work, Fraser offers space and astronomy news, covering everything from the Big Bang to the latest and greatest spacebound missions. So if you enjoy science and technology and all things space, I couldn't recommend Fraser's work enough. And again, Fraser, thank you so much for taking the time to speak with me.
Thanks for having me, Tyler.
Of course.
Feels weird to be on the other side of the recording,
yeah.
But
do you get the chance often? I was looking into your background, I didn't see too many interviews with you as the focus.
There are a few. Yeah, I actually, and I will repost them in my podcast feed. So if you're cool with that, I'll repost this one in my feed as well. Unless it sucks, and then you'll never hear from it again.
I very much hope that we walk away from this without that feeling.
Yeah.
So in terms of your start, again, when I was looking into your background, I didn't find too much about how you got to sort of where you are today. I know you started Universe Today in 1999. Mm-hmm. And then from there, everything sort of snowballed quite organically. So I'd love to hear a little bit more about how you got from there to this space empire.
Yeah, I've always been interested in space and astronomy. As a little kid, my parents were both very scientifically minded. We would go out and watch meteor showers and lunar eclipses, and I learned my constellations from my parents. My dad woke me up early in the morning to watch the first launch of the space shuttle in 1981. So space has always been a really big part of my life. And like I bought my first telescope when I was 14 years old. I organized star parties in my hometown. And even when I went to high school, I joined the journalism program at high school and reported on space and astronomy stories for my student colleagues. I don't know if anyone was really as into it as I was. The crazy part was that I stopped doing all that and went to university to go get a regular job. And I went into computer science and worked for a big tech firm out of Vancouver and building websites. But I always got this sense that there was a better way to run a website than the advice that we were giving to our customers, and that I was... I didn't fully understand it. So I said, well, I'm going to start a website on the side and run it the way I think websites need to be run in this modern age, of 1999. And that was very much about providing information on a regular basis every day, that no one really built websites like that. And my instinct was that the website was not about creating it in the first place and then moving on to some other task. It's a living, breathing entity that you need to care and feed on a regular basis. So I just picked one of my hobbies at random. I was always into astronomy. I like mountain biking, video games. It could have been anything. But that was the one that I both felt like there was a lot for me to learn and a lot of ways for me to be able to share this information and learn as I went. So I built the website and learned a ton about how to run a website, that I was able to give this information to the clients. But I also learned that this is all I want to do with the rest of my life. And so now it's a matter of like, when can I escape the corporate world and just be a blogger, space journalist forever? And that was the challenge.
And I can only imagine how the conditions were in the late 90s, early 2000s. I mean, that was foreign territory for everybody. So how did you really go about it? I mean, there was very little information, and the web traffic in general was so much smaller than it is today. How did you promote it? How did you share it?
Well, I mean, there not being a lot of sources out there is also an advantage in the early days.
True.
You get this first mover advantage. And so there was, like, back in the olden days, there was a pretty established mainstream media take on space news. There were reporters at the different, at MSNBC, at CBS, at CNN, who reported on this stuff and did a really good job. And so I was able to sort of aggregate stories from different people and places, as well as press releases from NASA and things like that. And just kept showing up every day. And that's the key. There's nothing more complicated or simple than you just keep showing up every day, and over time people find their way to your work, and as long as you make it better to be a part of the subscription than worse, then people will stick around. And I'm sure I have people who signed on back 25 years ago and are still subscribed to my email newsletter that I send out on a weekly basis, or visit the website.
Sure, I don't doubt that at all, especially because you cover such a wide range of topics. So there's definitely something for everybody as long as you're broadly interested in space, science, technology. And on that note, again, you cover such a wide range of topics. So I got to imagine that there's some that are more personally appealing to you and others that are more for your audience. So what are the topics you're keenly interested in? Is it more
you're totally
rocketry?
wrong. Yeah,
oh,
so
really?
You're absolutely wrong.
Okay.
Universe Today is absolutely my personal curiosity. So every day I sit down and I dig through all of the news sources that are out there, from press releases to journals to conferences that people are having, and then I have lots of other sources of news, cool pictures that people are taking, and then I only share the stuff with the writing team that strikes my curiosity, that sort of meets this very particular requirement that I have. So actually I have no interest whatsoever in reporting on stuff that I think the audience is going to appreciate, but I'm not interested in. I assume that everybody who's reading our stuff is as into the exact same things that I'm into, and if they're not, they'll find another website, which, I think that's the only way that I can be honest about what I'm doing, right, and keep myself entertained. So no, I'm 100% into just kind of following my own curiosity, and the readers get to kind of come along for the ride.
See, it's funny you say that, because so many of the guests I've spoken to, actually that was sort of my assumption, speaking to a lot of online content creators and science communicators, but I've actually found that many of them have sort of expressed the opposite. So, I mean, frankly, I prefer that approach. That's sort of the approach that I'm taking. I mean, any topic or person has to be something that I'm interested in, and obviously sometimes there's more of an overlap with what I might expect an audience prefers. So that's definitely sort of how I view it. But so with that said then, what are some of the specific topics you are more interested in? Again, rocketry, mission control and design, astrobiology.
Yeah, I mean, like I'm interested in everything from cool pictures of space to interesting news from space telescopes to amateur astronomy to space physics but when you really dig into it, there's a very specific kind of story. Like it, when you think about like narrative fiction, there's only whatever it is, 3 different kinds of stories or 20 different themes, or I don't know how this works. But there's a theme that I return to again and again and again, and this is what keeps me excited. And this is this idea of either a solution to a problem. So there is there's a troubling mystery with fast radio bursts, or there's a problem with a piece of hardware on the James Webb Space Telescope, or there is a mystery of gravitational anomalies in the outer solar system that's affecting the positions of the Kuiper Belt objects, right? There is this mystery. And what I love is people thinking of solutions to try to answer that mystery, or people who have come up with a new piece of evidence that locks another piece of the mystery in place, or a clever new idea for technology or a new kind of telescope that can help us reveal this mystery. So I'm always looking for stuff. I'm always attracted to stuff that is scratching this very specific itch that I have, which is I'm curious and I want answers. And if I can't get the answer, then at least someone having a clever idea on how they might find the answer is the thing that I'm most interested in. And so I actually, as I've matured as a space journalist, I've gotten a lot less interested in speculative stuff. Like, I'm not really excited about the future of humanity 10,000 years from now when we're traveling in our warp drive spaceships from world to world, or what a human colony on Mars is going to look like 1,000 years from now. Like, I feel like all that information, like that feels like you're kind of pandering to science fiction fans, and over time I just get less and less interested in that kind of thing. What I'm really interested in is the stuff that's on the bleeding edge. What is the new principle that's been discovered? What is the new technology that's being proposed that could show up in 10 years, 20 years? I'm always looking to the future, but I'm always looking into the near future, and that's the realm that I like to play in.
Yeah, and one of the best examples of that you already mentioned, of course, is the James Webb Space Telescope, which is something I've spoken to many guests about. And in your case, I find it particularly interesting and exciting because, as somebody who's, as you said, had been a space journalist for several decades now, I imagine that was sort of one of the highlights potentially of your entire career, and of again, so long waiting. And now, here we've almost already gotten used to it. So how did that feel to watch that launch and start to see the data come in?
Yeah, I mean, for my entire career, pretty much has gone in lockstep with the James Webb Space Telescope. And so for 20 years, we were reporting on the development of it, the ideas for it. And it is like the perfect example of the kind of story that I'm absolutely fascinated about. How do we see back to the beginning of the universe? How do we peer through the gas and dust that obscures newly forming planetary systems? Can we detect the trace gases of an advanced civilization that's polluting their atmosphere? James Webb is the machine to do all this. And for the longest time, the stories were, it's late, it's over budget, here are the missions that have had to be canceled because there's no budget left because James Webb ate it all. And it just felt like you were just watching this glacier grind across the landscape, gobbling up budget. And suddenly it's in space. And suddenly it's taking these pictures which are beyond our wildest expectations. And it's doing science at a breakneck pace. And we're just getting started. Like, I don't know, I feel like we're almost kind of fortunate because there is this quiet period that the astronomers get when they request data on the James Webb Space Telescope. They've got up to a year before they actually have to report their findings, and then the data is released to everybody. And it feels like there's been a lot of news coming out of this telescope, but there actually hasn't been. Mm-hmm. It's been tricky for us to find stuff. You have to dig pretty deep into databases to find interesting information. But those times are starting to run out. The first scientific data was gathered back last July. And so starting July, all the data that's been recorded by JWST is going to be published in publicly accessible archives for anyone to go through and dig through and find information. And so the astronomers are kind of on a bit of a clock. Now, some information is published immediately, but a lot of it is just is held in this embargo period for the astronomers. And so right now I feel like we're still just kind of picking up table scraps that are falling around. Every now and then we get an interesting story, but the tsunami is coming. And if you're interested in the news and the findings that are coming from this telescope, just you wait another 6 months, and then it's just going to feel like you're drinking from a fire hose.
It's so amazing. It's really so amazing. Every once in a while, again, I'm one of those people who got used to it rather quickly. And then, every so often I've been reflecting, like, it's there. It's doing science right now. Yeah. And as you said, the tsunami's coming. So yeah. I imagine you've spoken to some of the people who might have a chance to get some time with James Webb. So do you have an idea of what that tsunami might be sort of composed of?
Oh, yeah. I mean, like, some of the ideas that we're most fascinated with, like, people ask me, like, when will we learn about TRAPPIST-1, which is, of course, this this red dwarf system that had, like, I think 6 planets orbiting around it, many of which are in the habitable zone. That data's been gathered. Those, the scientists are studying this and trying to reveal information about it. And we've seen what this telescope can do with other exoplanets, detecting the presence of carbon dioxide and sulfur dioxide in their atmospheres and all kinds of really interesting discoveries. Somebody knows the answer about the TRAPPIST-1 system. There's the Proxima Centauri system. So there's a known planet orbiting, at least one planet orbiting the closest star to the sun. And it's in the habitable zone. So that's interesting. Yes, please. There are a lot of really interesting, fairly famous objects. There's Fomalhaut, which is the homunculus nebula, which I'm sure you've seen. Anyway, there's a bunch of these objects that have already had their information gathered, and now we're just waiting for this to come out. You can actually go, and there's a page you can see with James Webb that shows you what the telescope is pointing at this week, every single object and the time. And you go through the list and you just like, yes, please. Yeah, I'd like to know about that. Yes, that sounds great. But then you have to wait for the information to come out publicly, which is a whole other debate that people have. But yeah, and so I look at that list and I just kind of salivate. I'm like, yes, I would really like to know the answer. I want to see those pictures, but you got to wait.
Yeah, and as you said, it's exciting. It's frustrating knowing how much is already uncovered, as you said, but knowing that there's always sort of a carrot on a stick leading you into the future is quite nice.
Yeah, 100%.
One thing I wanted to run by you that is also something I've covered with a few other guests is, James Webb is ultimately sort of famous for its spectroscopic capabilities. And one of the most exciting things, at least in terms of astrobiology and the search for extraterrestrial life in general, is the search for those, what we consider to be anthropogenic gases. And the criticism, I suppose, that I keep putting forth is, the distances at which we're probing with James Webb are obviously enormous. And even if we are to detect spectroscopically any number or any combination of these different gases, it's sort of a dead end. Obviously, it's fascinating and it gives us a direction, but there's not much more we can do with that information beyond sort of indirect analysis and probing. So if we do detect some of these gases, what do you think might be the next step?
Yeah, so I think I disagree with you. I think that is the standard way that science works, is that you cast this wide net to see what's out there, to find the interesting anomalies, the observations that you can make. You're always seeing the low-hanging fruit. Like when you think about planets, right? For the longest time, the only planets we knew about were these giant hot Jupiters, planets that had many times the mass of Jupiter, that were orbiting around their star, taking just a few days to go around. Not because they're common, but just because they're easier to find than an Earth-sized world orbiting around a star. And so JWST is the first observatory that maybe, potentially, possibly has the ability to detect these gases like, say, chlorofluorocarbons in the atmosphere of an exoplanet. And that's not even certain. It's with just at the very outside realm of this, and yet a detection of potential signal for detecting chlorofluorocarbon in the atmosphere of another world, that has the potential to be one of those monumental discoveries in human history, and it's worth a follow-up. And so for every general purpose telescope that exists, astronomers have imagined a single purpose telescope that could do follow-up observations and answer the question much more precisely. And at the same time, you think about new ideas just for telescopes in general, like sending a telescope out to the solar gravitational lens, like 1,000 astronomical units from the sun. At that point, you use the sun as a lens that would then give you a 1 megapixel image of an exoplanet. So it's not just 1 pixel, a million pixels. You would see mountains and oceans and forests and clouds. You could see the weather that's going on this planet. Then you match that with some kind of device that's designed specifically to detect chlorofluorocarbons, and you're going to get a very powerful signature if that gas is there. And so whenever you have astronomers, scientists in general, but astronomers are always having this balance between, do we want to build a general purpose machine like the Hubble Space Telescope that can see everything and as pretty good? Or do you want to build a machine that tries to answer a very specific question? There's an upcoming mission called Ariel by the European Space Agency, and its job is to measure the atmospheres of exoplanets. It can't find planets. It only can study the atmospheres of the planets that we already know about. But it will do it even better than James Webb, even though it's a much smaller telescope, because it has this one job. So I think that it's always this iterative process where you discover something interesting, and then astronomers try to make the case for the funding agencies that they need a specific telescope or instrument or experiment that can get better evidence. I mean, think about the Large Hadron Collider, right? There is this enormous multi-billion-dollar particle accelerator in Europe, and its main job is to confirm the existence of the last building block of the standard model of physics. They knew about all the other particles, but they'd never found the Higgs boson, and they knew that it would take them this size of a machine to find it, and they found it with a level of precision and accuracy that nobody can argue with. But that's it. It can't seem to go any farther. So maybe they need a bigger machine to find the next step. And so this is just always the process.
And you also just highlighted very nicely the importance of scientific funding and just how much of a bottleneck it is, how we have the technology and we have the ideas and so on to develop all of these specialized tools and probably get the answers to many of the questions we've been waiting for. So I think you could probably speak on this more, of course, but over the last maybe 10 years or so, it seems like there has been a bit of a resurgence in widespread mainstream interest in space science. So do you think we might expect some more funding? Or perhaps you don't think there has been a bit of an uptick in that interest?
Yeah, I mean, but I'm like in a bubble, so I don't know what
Sure.
is the level of widespread interest in space news, because I'm just like surrounded by people all the time who are into space news. So I guess you'll have to tell me. But because I feel like it's never gone away. And people are like, oh, how come everyone's, people have been asking me for like 20 years now, why is everybody so interested in space now? I'm like, wait a minute. Like, if everybody always thinks that everybody's always interested in space now, they know everybody is always interested in space, and everybody loves space. So, I think funding is always a challenge, and governments have a set amount of money that they can set aside to fund all of the sciences, and space is just one of those sciences. And there are, if there's like dual purpose, like if you're going to create a military weapon, like when you think about like DARPA and NASA collaborating to build a nuclear thermal propulsion engine, it's going to launch in 2027. There's some money coming from the U.S. military to build this thing. And thanks, says NASA, for something that we wouldn't be able to do. But part of you's got to go, but it could be used as a weapon of war. So no, unfortunately, science funding is science funding, and it's always a battle. I mean, you talk to any scientist, and most of their job is not doing science, it's trying to get funding.
Yeah, and I guess that was the silver lining with the Cold War space race, and perhaps might be somewhat parallel to our future, because you hear a lot of talk about a potential space race with China. Mm-hmm. Does that excite you or scare you more, just based on, because that was the pinnacle, arguably, of interest in space and where funding was much more prevalent than ever before?
Yeah, I mean, it's always nuanced, right? It all depends on how it all acts out. So if China sends people to the moon, sends people to Mars, builds a robust space infrastructure, and uses it in purely peaceful purposes and advances science and so on, that's all great. My ideal is that there's collaborations between other nations and China, like what we had with the International Space Station. I mean, despite the war in Ukraine, Russian astronauts and American astronauts are working together, and I'm sure they're great friends with each other. And I think that was one of the geniuses about building this as an international community, right? It's got a Canadian space arm, it's got European astronauts, it's got people from Japan, and unfortunately never had anyone from China. And so I would love to see that kind of a collaboration. But you can imagine a dark side where China, like when you talk to Chinese people, there is a respect an enthusiasm for science, space, and technology that doesn't exist in the West. That is, you talk to most people in the United States or Canada or whatever about space astronomy, and they mostly don't care, right? And there's a lot of skepticism about expertise. But that is not the case in China. There is a level of enthusiasm for their growing technological capability that is quite inspiring and a little unnerving to think, like, why are we not that way too? And like that compounds. And so I can imagine people who are watching as their technological growth continues and as the baseline enthusiasm for what they're doing is solid, as people fight to get their kids into technical universities where science funding is growing, and then you match that with an authoritarian regime that has no problem canceling voices and shutting down access to outside news, like that can't be great. So I am ambivalent about this whole process. Like, I am excited for anybody who wants to build a giant radio telescope and try to study the universe and share the knowledge, or build a new cool space telescope. I'm less interested in authoritarian regimes using their technology to put more control over their citizens. And unfortunately with China, that's what you get. You get both of that.
Yeah, I mean, needless to say, I couldn't agree more. And what do you think is the cause for that difference in opinion and difference in perspective, I guess, between people in the Far East and people here, or just across the West broadly? Because it seems to me that intuitively I might expect that we have the reverence and the very, very widespread interest in these topics because we have the communicators. To be honest, I don't have data on this, but I have to imagine that the West has a much higher frequency and much more popular science communicators. No, there are many more in the East.
Like, one of the cool things, like, I'm learning Mandarin Chinese for fun.
Nice.
And so you spend time reading sources in Chinese and Weibo and WeChat and things like that. No, there's a very robust science communications establishment in China that is sharing information. There is a whole shadow ecosystem of science communication, with people going down to the various launch sites and doing live streaming on the Chinese version of Twitch and on Bilibili and things like that. So no, I think there is as much science communication that's happening in China as there is in the West. And from my experience as a science communicator, it doesn't seem to have the same amount of negative pushback and conspiracy theory and kind of low grade meanness that we see here on Facebook and Twitter and YouTube and stuff, right? Like one does not simply just read their YouTube comments. It's you got to go in with a stiff drink and a firm spirit, it's tough. So no, I think that there is, and I have a fairly arm's length understanding of this today, and this is part of why I want to understand this more, is that I think that there is there's more than a billion people that speak this language, and there is a very robust ecosystem to share this information and to discuss it. Is definitely overshadowed by an authoritarian regime that is attempting to control who says what to who and how much and what things can be said and so on. But still, it's quite robust.
Yeah, I mean, again, needless to say, I share your sentiments about the authoritarian regime, but I've got to say, I suppose, I'm hesitant to put it exactly this way, but the silver lining, I suppose, is they do maintain steadily their trust in institutions. And in the West here, I mean, we've really lost all faith, and it's scary that it's extended to NASA, the European Space Agency, and so on. I mean, we have large swaths of people denying even sort of the most basic things. So how do you imagine that moving forward? Do you think that we'll sort of recapture that, or
Who knows? But it can't be good.
yeah,
Right? That's all. Like when you have to deal with people, the sort of like when I post stuff on Facebook, say about a Mars landing, I would say
oh God, yeah,
50%, maybe 75% of the comments are eye-rolling, pseudoscientific, conspiracy theory believing comments from people. And 25% are, oh, that's a cool picture. Oh, look at that rock. Or like the rover is, I can't wait to hear the results of this experiment. 75% are people saying, oh yeah, it's just, wake up sheeple. So how can that end well? How will it change?
I think, I mean, I guess there's many answers. As far as I'm concerned, and a very sort of milquetoast answer, but education. I mean, whether it be through the school system by people like yourself, I think it's just having the conversations and getting people exposed.
Yeah, I don't see my children didn't have a wonderful, inspiring educational experience. It was a place they tried to get in and get out of as quickly as humanly possible with the minimum amount of damage, right?
Yeah.
And so their hearts weren't in it, and they're finding who they are now. Like once they're out of school, and they're finding the things they love, and and I get to be a presence in their lives and help them connect them with people and research the things they like, and I support the things that they enjoy. But school doesn't do it. School is a place where you go and are taken care of for the day while your parents
Glorified
go to work.
Babysitting.
Yeah, exactly. And I think, but you see immigrants who come to a place like Canada, and there is a totally different mindset. They know what suffering feels like. They have left a place. They've left their home to go somewhere else for a better opportunity, and they're going to make the most of that opportunity. And I think that this is just a natural cycle that you if you have less and you see people with more and you want more, then you focus on the things that matter to get you to that more. And whether or not more is a good thing, like I could absolutely agree that more is bad, but you can see people who come from immigrant families focus on education. They focus on these kinds of opportunities, carefully saving, etc. And like obviously this is a generalization, but but you can see this cultural sort of legacy, and I think that because China has went through a long time of a lower gross domestic product for various people, and then their rules were opened up in certain ways, then they were able to expand their sort of personal standard of living, and they want more of that, and they know that education is tied to that. Or maybe it's that authoritarian regime that just stops people from expressing their flat Earth conspiracies. I don't know. But I don't
probably
think,
a bit of both.
But I don't think distrust in experts will end well. But I also don't think, I think a lot of people, when they see this situation on the internet, and they get really sad and they think that everything is hopeless. But we are going through a moment in human history, the advent of the internet, the ability for all of humanity to interact and connect with each other in a way that's never been possible before. It is as monumental a shift in society as what happened with the Gutenberg Bible, right? With the printing press, with the written word in the first place. Like these only happened once. And we've seen what happened to human beings at previous times. I mean, millions of people died in wars because of the printing press. And we don't have that level of dramatic upheaval going with the advent of the internet, and yet I think the impacts are as dramatic. And so I see this as a novel threat to the human mental sort of immune system, and that we will figure out ways to deal with it, to deal with attempts at misinformation, to deal with, we're going to build up our antiviral capabilities, our antibodies, to the point that these things don't work anymore, and we get all the positive benefits of being connected with other human beings. Like here we are right now talking, right? Like how did you find out? Through the internet.
Exactly.
And then you booped me on the email, and I said yes, and now we're recording on a piece of software, and I'm in Canada, and I have no idea where you are. And
Arizona.
there we go, Arizona. And we can have this conversation in real time, and that is amazing. And so, like, let's have that without people rolling their eyes and calling me a globetard on Facebook. And I think we'll get there. I think maybe it'll take us 10 years, maybe it's 100 years, but all of humanity will only get connected once, and this is that time.
Yeah, and again, I couldn't agree more. And I guess we should expect some growing pains. I mean, as you said, it's a fundamental society-altering technology, and I guess to expect that we wouldn't have some form of these problems would probably be naive. So it's a good point.
Mm-hmm.
Another, shifting gears a little bit to get to another, I guess, more technical topic, is I want to go over artificial intelligence a little bit, and not in the sense of asking you to, as you said earlier, look 1,000 years in the future and consider our machine overlords, but rather AI as a tool for astronomers, because I think there's not enough attention about how that's used as all of these machine learning algorithms for data processing and analysis. I mean, it's incredible, especially for astronomy. So if there's anything, how much do you know on that topic?
Lots. Yeah, tons. Yeah, my degree's in computer science.
Oh,
So I'm very familiar and have been playing around with artificial intelligence to sort of see the state of it. I haven't figured out a way that it can help me do my job, and that's probably best. I played around with some of the image creators to see if I could make interesting, fanciful images, and I was able to make a series of foods that looked like planets. So I made like a sandwich that looked like Jupiter and a bowl of soup that looked like Neptune, but I didn't see any practical use for this technology in what we do, because accuracy is key. And right now, the current state of the content generation, the artificial intelligence, the accuracy is the computers lie and in a very believable way. And so you have to go, you know what? I'm just not going to. I don't have time to fact check everything you say, so I'm not going to believe you. But machine learning, in general, is an incredibly powerful technique, and astronomy, modern day astronomy, is a data problem. In the olden days, say 10 years ago, 20 years ago, like if you had a mystery that you wanted to solve, you booked time on a telescope like the Hubble Space Telescope, and then you gather data, and then you look through the data to try and make some kind of conclusion. Do you see the signature of oxygen in the atmosphere of that planet, or do you detect the redshift of these galaxies as they're moving away from you? But it started in the 2000s with the Sloan Digital Sky Survey, which is this comprehensive database of millions of galaxies, and it's just grown over time. And so now we have these surveys. We have the Gaia survey, which is characterized the movement and position of over 1 billion stars in the Milky Way. We have the latest edition of the Sloan Digital Sky Survey, and there's the Dark Energy Survey. So there's now probably a few dozen surveys that I'm not even aware of, and more coming around. There's going to be the Vera Rubin Observatory, which is coming out maybe later on this year, that will produce just an extreme amount of information. And so now the job is not, do you book time on a telescope? The job is, can you wrangle the data to give you some kind of answer? Because now, instead of finding and studying one white dwarf, you can simultaneously study 1,000 white dwarfs, 10,000 white dwarfs that have been found in the Gaia data. And that means being a programmer, and that means developing algorithms that can help you come up with these answers. And the thing that machine learning is very good at is identifying patterns in things that you can say, this is a cat, or hot dog, not a hot dog, hot dog, not a hot dog, right? Or white dwarf, not a white dwarf.
Yeah.
And then after you train the machine learning algorithm, you can then feed it these enormous databases that no human being could ever go through, and it provides information. And then you have lots of other really interesting applications, like when people are trying to explore Mars with a robotic spacecraft, and it's a 20-minute time to be able to communicate with the spacecraft, and the spacecraft is landing in a boulder-strewn nightmare landing site. Well, you teach the spacecraft how to recognize good and bad landing locations, and then it is performing that analysis as it's falling through the atmosphere of Mars. And that's what we saw with Perseverance. Like, Perseverance chose its landing site because they had used machine learning and trained it and go, like, rocks bad, sand good, right? Avoid this. And it kept learning and learning and learning until it could choose and drift itself towards the better landing sites. And then it did it. When it landed, it picked the landing spot, made sure that it was perfectly positioned away from dangerous hazards, and set down perfectly. So there's a lot of ways that machine learning algorithms and artificial intelligence is going to give just huge amounts of value, both in studying these vast databases that astronomers now have to go through, but also helping our spacecraft make decisions when they're far away and the communication times are too long for them to be able to make any kind of decision.
Yeah, it's really unbelievable how much it has to offer. And one of the things that's most, at least exciting for me, is sort of the potential for serendipitous discoveries. Because as you said, it excels at this pattern recognition capability. So who knows what it might sort of just bring to our attention just through working through all these data sets.
Well, and we're seeing that. I mean, there are, and this is why the Vera Rubin Observatory is so exciting. This is this telescope that's down in Chile. It's going to be scanning the night sky to an incredible depth every 3 nights, that the southern hemisphere. And it will find all of the things that the universe was doing when we weren't watching. It'll find asteroids moving. It'll be the thing that finds Planet 9. It'll find Kuiper Belt objects. It'll find new supernova. It'll find variable stars. And it'll find weird things that we didn't even know existed because nobody had been watching the sky with that kind of a cadence. And, in the immortal words of Isaac Asimov, right? The great discoveries in science, they don't happen when, someone says eureka. They happen when someone goes like, that's funny.
Yeah, exactly. And speaking of asteroids, obviously you spend a lot of time on the channel speaking about sort of existential threats, whether they be asteroids. Recently, I've noticed a lot of conversations about solar flares, and that's one that's of particular interest to me. So through these conversations and your research on this topic, how concerned should we be? I guess, first of all, across these different threats, and then is there one in particular, maybe solar flares, that might be most
like
pressing?
Space-based threats? Yeah, so like a lot of people are concerned about asteroids, and I think you can safely not be worried about asteroids at all. Yes, asteroids inevitably crash.
That's going to be
into Earth,
comforting for a lot of people.
and when they do, they cause a lot of damage. But the good news is they happen very, very rarely. When a damaging asteroid happens once every 500,000 years, and so your chances of being around when one of those damaging asteroids is going to hit us is very low. And NASA has done a pretty great job of categorizing the positions of the most dangerous asteroids and has mapped them to say none of these are any threat to us for the next 1,000 years or so. And NASA is launching a new spacecraft called the NEO Surveyor, which is going to categorize the less damaging asteroids. So anything that causes any kind of damage, we will soon know the threat assessment of every single one of them. And NASA just recently tested the DART mission, which crashed a spacecraft into an asteroid, and it worked surprisingly well. And we learned that, in fact, if there's an asteroid on a collision course with Earth, that we can probably shift its orbit a significant amount. So if we've got enough notice, thanks to the NEO Surveyor spacecraft, we should be able to eliminate any potential future threats. So no, asteroids are not of concern. Supernova, if you're within a few light years of a supernova going off, that's a very bad day, but there are no stars that have the potential to go supernova in our vicinity. We're fine from that. Maybe there's going to be some other stuff. The one that does keep me up at night is solar flares. And that is, we know that when a big solar flare hits the Earth, it can cause a spike in electrical systems that can cause these cascades of failure. The more interconnected your wires are, the more charge can be jammed through the wires and can break transformers, relay stations across the board. And in many cases, these are very expensive, very custom pieces of electric equipment. You take down the electrical system for the eastern seaboard of the United States for a month, right? While everyone tries to scramble and put that together. Like, imagine your power goes out for a month, where 100 million people's power goes out for a month. Yeah, like that's tricky to deal with, and we see those kinds of flares happen on a very regular basis. I mean, the last really bad one that hit Earth and caused damage was back in 1989 when a flare hit Earth and took out a power station in Quebec and caused a lot of damage. But we've seen storms that are as powerful or more powerful than like the Carrington event, which was this one that lit telegraph poles on fire back in the 1850s. We've seen them, and so we know that really is just a matter of time before one of these solar flares hits us. And the more, and that's a us problem, right? The more we develop technology, interconnected technology, the more we rely on satellites, the more vulnerable we become to a devastating solar flare.
And is there any potential to sort of insulate our grid and our electrical devices in some capacity? Because I feel like
this is all solvable, right? Like you just have to not do the thing that's the cheapest. You have to do the thing that's more expensive. You have to you have to put in the redundancies. You have to harden you have to go in and retrofit a transformer or a relay station to harden all of the electronics, to give it ways of disconnecting when it senses a power surge coming through the wires. Like there are known solutions for every single one of these problems, but it's just an infrastructure issue. And why fix it when you can just go another year and just skate on, hoping that you aren't going to have that killer solar flare? So, I mean, this is just classic human behavior at this point.
Isn't it amazing how the governments do ultimately give billions of dollars for this type of research, and you would expect the lessons to be swiftly applied? I mean, that's why they're giving the funding, is to learn about something like solar flares and go.
No, it's
well,
you'd
hope
learn
at
about
least
something and actually implement the fix.
Sure.
The fix is trillions of dollars.
Yeah.
Right. To utterly change the blueprint of the way electrical devices are connected together at large scale. To retrofit the transformers and things like that to be better hardened from solar flares. And it has no function, no value really, except when the solar flare hits. And it might not hit for 1,000 years. So I think it's we see examples of that where people live on floodplains, or people live in earthquake-prone areas, or downstream from volcanoes. Like that's human behavior. That's how we roll, man. And so to expect that we're going to choose the path that is reducing the risk and investing in the future and hardening our infrastructure is pretty hilarious.
It's reminiscent of the pandemic. We had epidemiologists and just for years and years saying this is inevitability. We should start preparing. It's going to cost a lot of money, but so I would tend to agree. I think it's just crossing our fingers. I don't know if I guess I hope I'm not there for it, but I also don't want to put the burden off on people of the future. So
climate change, all this stuff. It's all the same. It's the same story every time.
You're right.
Space debris, right?
Yep.
It's the tragedy of the commons. And we will never learn that lesson.
You think never? Ever? Like, no matter how far we get, do you think it's something we won't absorb?
I think we always are living on the ragged edge of... And I think it's just like it's human behavior. I mean, we're way outside my expertise. But, like, why is it that our bank account always reaches zero right when it's payday? Right?
Mm-hmm.
Like, that's because that's how our psychology works. And I think a modern society with all of its interconnected moving parts is that concept at the vast scale.
Yeah. Again, I wish I could disagree, but sadly, I think you're
Yeah.
completely correct.
Yeah. I mean, we can make
So
changes in our own lives. So, be more
yeah,
robust and self-sufficient and less prone to black swan events in your own life, and hope that others will do the same.
yeah, no, absolutely.
Have you
And
got an
I would be
emergency kit in
great.
your house?
I am guilty of not taking any
See?
of the precautions. Yeah,
There
no,
you
I'm
go.
guilty of it too. I definitely
Right.
don't exclude
Yeah,
myself,
like what
but
is
it
it?
is
It's like
amazing.
a day's work and maybe $100 to put
Yeah.
all the stuff together that you need to have an
Yep.
emergency kit, and you haven't done it.
It is funny. I've had these conversations with friends, sort of many adjacent conversations, where it is amazing how you can just make a bad. You can consciously, rationally recognize I'm about to make a bad decision, and you'll move forward with it just
Yeah.
the same.
Yeah, because you're just
unfazed.
making
It's-
this risk assessment, right? Like,
Yeah.
like we are terrible at 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 assessing risks that are remote but catastrophic,
Yeah, exactly.
right? We're fine at assessing risks that are mild and likely, but really bad at the remote catastrophic ones. And it's only when the insurance industry has helped us set up to make sure that if your house burns down, you can get it paid for. And they've gotten very good at taking that pain away from the. If we all had to self-insure ourselves, it would never get done.
Screwed.
Right?
Yep. Nope.
So instead, you pay someone and they take a check from you every month, but if your house burns down, you're covered. So that feels. So I think there are glimmers of that, right? like as much people, I'm sure nobody loves the insurance industry. When your house burns down and your friends ask you, "Did you have insurance?" You're like, "Yes." Suddenly you're okay with it.
You're a big fan.
Yeah, exactly. Yeah.
So to get back to as you said, the bleeding edge of ongoing research, with James Webb not having come and gone, but at least the launch being successful, what's sort of on the horizon, no pun intended, of what the most exciting sort of gargantuan next mission is to be?
Yeah, so I mean, I've made a couple of references, but I would say the one that's going to make the biggest difference and the one that's going to feel like the second fire hose of news is going to be the Vera Rubin Observatory. And this is this previously called the Large Synoptic Survey Telescope. And it's the biggest camera that's ever been made. It's like a 4 gigapixel camera. I forget the size of it. It's
Something, I
enormous.
think something like that.
Yeah, yeah. And the telescope, like the primary mirror on this telescope, is the same size as the Very Large Telescope, the individual components of the Very Large Telescope. It's an 8+ meter telescope. So it's a very big telescope, but also has this enormous camera system, and so it's just very fast. So it takes a new picture every like 15 seconds of a huge swath of the sky. And it's not just like a surface level picture. It's actually able to see really faint objects in that picture and then move on to the next frame and move on to the next frame and then dump all this data. And so all of these interesting one-time events are just going to happen, and they will be freely available to anybody. Like there's no proprietary time on a survey telescope like Vera Rubin. Anyone who wants, even you, listener, if you know how to make a database sing, you can pull this data out and start discovering asteroids and name them after your friends. So it's going to be just a fire hose. And then around the corner from that, we have the 30-meter telescope, which is also going to be the Giant Magellan Telescope, which is also going to be in Chile, and that's in 2025. And then in 2027, we get the extremely large telescope. This is a 39
Running out of words.
telescope. I know, I love the names. It is again, like right now, the biggest telescopes on Earth are around 10 meters across, and this one's going to be almost 40 meters across. And it will be powerful enough that it can detect Earth-sized worlds orbiting around sun-like stars, which is the holy grail of exoplanetary research. And so there's a lot of these giant ground-based observatories that have been in the works for a decade more and are now coming to fruition. And then in terms of space, I mean, obviously we've got the Artemis missions. We saw the first launch of Artemis, but we've got the next Artemis mission coming up in a couple of years. And then after that, humans set foot on the moon again. We've got the Titan Dragonfly, which is going to be this nuclear-powered helicopter that's going to Titan. we've got the Europa Clipper mission, which is in a couple of years, it's going to be returning to Europa, which is Jupiter's moon and the one that's thought to contain an ocean of water underneath the ice. We've got the Nancy Grace Roman telescope, which is essentially a clone of the Hubble Space Telescope. So it's the same size, but it has a vastly wider field of view and has much better electronics on board. So, like, if you liked Hubble, now we get a second one, and that's launching in 2025. So, and, you know, people just ask me this, like, you know, what's coming? You know, there hasn't been a lot of interesting things happening, right? But actually, it's nonstop, the really cool things that are happening. And now we see a lot of other countries getting involved. The Indian Space Agency has some terrific missions, and they're moving towards human spaceflight, building their own space station, a lot of cool missions. The Chinese launch as many rockets every year as SpaceX does. Like if you look at the countries, the US is number 1, China's number 2. But if you look at launch providers, it's often a dead heat between SpaceX and China. So they've got their own space telescope that they're going to be launching. That's going to be kind of a Hubble class telescope, but it's going to fly in formation with their space station, and they're going to be able to dock the telescope to the space station to do repairs and upgrades and add new instruments, and then push it away and let it float free again. But they've also built the largest radio telescope, like Arecibo, like a great big stable dish, but they're also building the largest steerable radio dish, which is coming out. We've got the square kilometer array, which is being built in both South Africa and Australia. And this is going to be a telescope, a radio telescope that has one contiguous, the equivalent of 1 square kilometer of aperture, of surface area on the dishes when you add up all of the separate components. So it just goes on and on and on. I could do this all day.
Yeah. I mean, what a decade for it. And can you imagine what we will know in 2050?
Mm-hmm.
I mean, it's unimaginable, truly.
So if you take the number of planets that we know, like right now we know about 5,800 planets, I think, with another like 10,000 planetary candidates that have yet to be confirmed. But you just take that number and you just chart it forward. It's, you know, with exponential growth, that we'll probably know about 50 million planets by the year 2050. If you just keep that number up.
Unbelievable.
Right? In the you know, we don't know how. Who knows how we'll do it? But there will be new technologies that will come online that will provide that additional information, and we'll get there. So it's it's quite a revolution coming.
And one thing I also love about several of those missions is I'm a big proponent, and I just find the whole space of citizen science and amateur scientists to be not only just a great thing, just as from sort of a hobbyist perspective, but I really think there's a lot of potential to sort of decentralize the scientific process, at least largely, and have people who are, I guess, on paper, amateurs, make very meaningful contributions. And I think astronomy is one of those fields where it's a lot more inviting, and there's a lot more sort of interconnection between the experts and the amateurs. So do you know if there's any ongoing work to sort of enable amateur scientists to make these contributions, or is it just sort of you get lucky?
Oh, yeah. I mean, like, I'll log roll in a second here, but astronomy is one of those fields. Like, I think like ornithology is the other one, but astronomy is one of these scientific fields that has had contributions from amateurs make meaningful discoveries in the field. Exoplanets have been confirmed by amateurs. Amateurs study variable stars, discover comets, discover asteroids, and then also work in collaboration with professional astronomers. And there's a lot of really interesting citizen science projects. Famous one is called the Galaxy Zoo, where people were classifying the rotations of galaxies and helping to identify them. And I'm part of an organization called CosmoQuest, which has similar citizen science tools, so allows regular folk with a little time on their hands and an interest of learning a little bit to be able to actually help do science. On the CosmoQuest platform, they counted craters on Mars and on the Moon. They were the ones who helped find the landing site for the OSIRIS-REx mission. They were able to
Amazing.
count all the boulders and identify every single rock on the surface of asteroid Bennu, so that when the OSIRIS-REx mission was going to make its landing, it could find the one spot that wasn't completely cluttered with boulders. So, and when you think about people who are citizen scientists, in many cases, these people are quite accomplished in some other field. They've always been interested in astronomy and astrophysics and planetary science. They just never got around to that field. And who can blame them? There's not a lot of jobs. It doesn't pay very well, but everybody loves space. And so you're going to have people who are electrical engineers or are physicians or, the scientists, scientifically minded people who are able to share a few of their brain cycles to work on some of these projects. And astronomy is one of those fields that really welcomes the contributions by amateurs.
That's so amazing to see, really. And like you said, I think astronomy is rather unique. It's that and a few other disciplines. I mean, archaeology, there's a few examples, but I really think it's not only, again, it's sort of an outreach program where you just want to get people involved and to take a liking to it, but I really think it could change the scientific process.
Yeah, 100%. Yeah, there is a partnership between amateurs and professionals in astronomy that is closer than almost any other field. Like I said, except for maybe like bird watching. Like bird watchers are...
That's the OG.
Yeah, exactly. Yeah, they've been doing that for
150
150 years and have been providing, they go to these giant bird counts and they provide all this data. And I can imagine what the ornithologists would do if they didn't have access to this data from all these people.
Yeah, and I would love to see that across all of the scientific disciplines.
Yeah. Because, I think you can't go wrong, underestimating the power, the level of contributions that amateurs can make to the work that you're doing. Like, if you give them a way and a place to coordinate and do their work together, what they can accomplish is often mind-blowing. It's just a matter of they don't want to step on your toes, and they don't want to waste their time. But if there's jobs that do need doing, then you can get their help. And I think that's what's wonderful about computers and even machine learning, is you can sit a person down in front of a boulder-strewn field on asteroid Bennu and say, mark all the rocks with a dot. And that's a thing a human being can do that a robot actually is very bad at right now. And then you take all this data and with redundancy, you've classified the same rock 30 times. NASA is very comfortable that rock actually exists and knows the dimensions of it. It takes hard work by a lot of people, but the results are nothing short of stunning.
And it links back to what we were talking about earlier, where I think one of the few ways to get people both educated and trusting of the science that's coming out is to get involved. Because if you sit there and you're doing the type of things that you just mentioned, you're not going to leave it going, I just, had an AI picture I was pretending to circle rocks on for 30 minutes,
Well, I get this question all the time. I know people, I think, as I mentioned before, right? Everybody loves space. It's like hating space is like hating kittens.
Yeah, exactly.
And I'll talk to somebody and I'll say like, what do you do? I'm like, oh, I'm a space journalist. They're like, oh, I love space. And I'm like, well, of course you do, because everybody does.
Yeah.
Right.
Yeah.
And then they'll talk to me about space for an hour. And I think a lot of people are astronomers in another life, right? Or space scientists in another life. They just happen to be a doctor and they happen to be whatever. And I think a lot of people, I get this question all the time where I'm like, should I go back to university and get my degree in astrophysics or get my degree in astronomy? And my general answer is no. Don't do that.
You'll ruin it.
Well, it's not even that. It's like if what you want to do is get a job in astronomy or astrophysics, you want to be a professional astronomer, you want to work at a university, you want to teach classes, and you want to do some research, okay, but it is an intensely competitive field, and the pay isn't great, and so it's not a great career, unfortunately, which sucks. It'd be great if it was. But if what you want to do is learn, the same kinds of stuff that professional astronomers are learning without all that stress of having to then go turn this into your career and follow your doctorate and have to break up with your partner because you got a doctorate in one city and they got a doctorate in a different city. Like it's a nightmare. But if you want to learn that stuff, well, then the universe is open to you. There's so many, like there's MIT courseware. You can go to various universities. You can take their courses. You can learn the equivalent. And there are all of these citizen science projects that you can participate in to actually express your ability. And then you get your name on the paper and you become collaborators with people. And especially if you have other skills to bring to the table. I mean, the thing that we talked about this earlier, the thing that astronomers really need is people with computer programming, database programming chops. That if you can come in and slice up a giant database to produce the kinds of queries that they're making, astronomers need your help. If you can write Python code, astronomers need your help. And they'll teach you the astronomy part, but they really need your help with the technology part. So if you want to help discover 1,000 new asteroids, you don't need to go back to university to do it. You just need to bring those skills to the table for the people who are doing this work. And there's, it's depending on how much of a self-starter you are, there's a lot of opportunities to get involved in. So that's always my advice is no, don't go back to university and get your PhD in astrophysics. Just help today.
Yeah.
And learn.
Again, couldn't agree. Yeah, because that's really the main point, isn't it? I mean, regardless of your level of interest, at the end of the day, it's a matter of learning a lot, learning a little, learning however much your schedule and your interest is in accord to.
Yep.
So we're coming up on time, so I'll ask you one final question, if that's all right. Whether you are aware or might admit it or not, you are certainly a scientific hero of sorts for many people. I mean, with as long and fruitful of a career as you've had. So I think it's always interesting to hear from people like yourself. Who are some of your scientific heroes, whether they're communicators or the people who made those massive contributions?
God. So I don't have any specific heroes. Like it's kind of weird to me because I've had the opportunity to interview everybody that I would want to be able to interview, which is just like such a gift. Like if I want to talk, I can talk to astronauts, I can talk to astronomers, I've talked to Nobel laureates. It's amazing. And to just be able to sit there, like you're interviewing me, right? To just sit there and just ask them all of your questions, and
exactly.
Part of your brain's
as good
going,
as it gets.
I can't believe this is happening to me right now, but you're trying to remain professional and keep your wits together. But what I love, and this isn't exactly the question that you asked me, but what I really like is when you have scientists who are primarily trying to do their work, but they also feel the need to communicate their work to the public and have a respect for that public communications side. And they don't necessarily engage in it, but they do spend time trying to make the things they do very understandable. So I think about people like David Kipping from Cool World's lab. He's a working scientist, but at the same time, he is an excellent communicator and leads a team. And then a lot of the people that have come out of the lab, Moy McTeer, some of the people that I've had a chance to work with, Kimberly Cartier and Morgan Renberg. So Dr. Pamela Gay, my co-host on Astronomy Cast, like those people who have the scientific chops, but also spend time trying to communicate that information to the public. I just have so much respect for the work that they do. That both are difficult, and I've only chosen to specialize in one of them, and I dare not tread on the other one. But they are able to straddle both sides of it, and I think that our culture is made better by it. And the one bulwark that we have against people rolling their eyes and saying "lol science" is these people who do the work, but also take the time patiently to communicate the work. And I think that, and I totally get that if you're a scientist, you're like, oh, I don't want to do this. I don't want to talk. I don't want to have to explain this kind of stuff. It's not fun, and it's not rewarding in the same way. But for the people who do it, it is just it's wonderful that they contribute, and I am so grateful for people who take the time to do it.
Yeah, I am similarly grateful, and grateful for people like yourself as well, because again, I've been watching your videos for I don't know how long now, and as you said, there are probably people who have been watching you for 20 years. So thank you so much for everything you do, and thank you for taking the time to speak with me. It's been lovely.
All right, glad to be here.